So hi everyone, this is the Knowledge Cube and I'm Ashwin here. So now we have covered many topics from input to dictionary sets, lists, type of conversion and etc. So now we are going to focus on another topic which is called as swapping variables. So let's say you have A is equal to 5 and B is equal to 10. And then now let's say you want A to be B's value, which is 10. Let's say if you want A to be 10 and B to be 5, what can you do? So you can just say A, B is equal to B and A. So now if we just say print A first and then B, and when I run this, you can see that we got 10, 5. So to brief you, A is the first one and B is the last one. So we have swapped our variables, right? So we wanted A to be 10 and it printed out 10 for A, and we want B to be 5 and it printed out 5. Okay? So now you got an idea of how to swap variables. So now let's go on to the next topic, which is operators. So this is a very interesting topic, okay? So this is very important. So now let's say that you want to check if a number is lesser than or equal to another number. So let's just say A is equal to 5 and let's just say print A and then you have to use the lesser than sign. Yeah, so this is the lesser than sign and then an equal sign and then 5. I mean 6. Okay, so you can see that we have a lesser than sign and equal to sign. So what does lesser than sign and equal to sign mean? So this lesser than sign and equal to sign mean that if A is lesser than or equal to 6, just give it true. Just return true as the output. So when I run this, you can see that we have got true because 5 is of course lesser than 6. Okay, so that's the same thing with greater than. You just have to change this to the greater than sign, and now when I run this, you get false because 5 is not greater than 6. Let's say you want to check if the number is exactly equal. So for that you have to use two equal signs. So why two equal signs? Because if you just put one equal sign, Python will think that it is a variable. Logic, right? Okay, so now we have got it. So when I run this, it just says false because 6 is not equal to 5. Okay, so now let's say you want to compare two things. So let's just say A is equal to 5 and then B is equal to 10, and then let's just say a print if A is exactly equal to 6 and B is exactly equal to 10. So what this will do, so I just explain it like this. So I just explain it by paint because this is actually a little bit difficult to understand. So I'll just say paint. So we have got a paint here. So for and, how this and keyword works is, let's say you have let me just take this. Okay, so let's just say this is A and this is B. Let's just divide this. This is B. So what you have to do is, if it is true, if A is true and B is false, it will return false. Why, you ask? It is because the both of them should be equal. Then only it will print true. So when I say A is true and B is also true, and the answer is true. Okay, so here is how AND works. So to prove you wrong, I'm just going to run this. You see, you got false because this condition is not fulfilled, so we got false. So this condition is actually false and this is true, so we got false. But let's just change this and see the output. And I'll run this again. So you see, we got true because A is exactly equal to 6 and B is exactly equal to 10. So here there's another thing which is not, OR. So what is OR? OR just means, now I'll draw the OR. This is, okay, let's just take that. This is AND, okay? AND table. So now we are going to look at the OR table. Okay. So let's just divide this A and B. Okay. This is A and this is B. So so let's just say A is equal to true and B is equal to false. So what do you think will be the output? Will it be true or false? Just pause the video and guess it, and you can even put it in the comment section too if you want it. Okay. So yeah, you have true and false. So here's the answer. It will return true. So because you see, OR just means if at least one condition fulfills, it will return true. But if both conditions fulfill, it will return false. So now if I just run my code over here, you see we have gotten true. Okay, that's weird. Okay, so that's wrong actually. So you see, even if both of them are true, it will return true. Okay, so that is the thing with it. So let me just say T for true. Okay, T if true and A is true and B is true, that the output will be true. Okay, so it's really easy, you can do it. Okay, so now we have seen and OR. So now let's just look at NOT. So for NOT, let's just define a Boolean value. So Boolean means, of course, you are saying true or false. Let's just say true, and I'll just say print not A. So what this will do, this is actually the complete opposite. So since A is true, this not keyword will change it into false. It will just convert it into false. So when I just run this, you can see that the output is false. It's not true. That is the thing with not. Okay. So now for the mathematical calculations. Okay. So now let's say you want to divide a number in Python. Of course, you just say print 5 and a slash sign 5. That's it. And now if we just run this, we get 1. But what's the 0? So Python actually says 1 slash is 0. It will return a decimal value. We don't want that. We only want 1, right? So for that you have to use double slash. So single slash means float division, which is also called decimal division, and two slashes is just integer division, which will just return a normal number. See, we got 1. So let's say you want to multiply two numbers. For that you have to use this asterisk. This asterisk will just multiply both of these numbers and you get 25. Okay, so there is this thing called as Python which gives you the remainder. This is really awesome. So when I just say 9 divided by 5, of course 9, you have to use the percentage symbol. So this percentage symbol will return the remainder of this division. Okay, so it's just division, but it will return the remainder, not the answer. Okay, so as you can see, we have got the remainder, which is 4. 9 divided by 5 is 5, remainder 4. But we didn't get 5, instead we got the remainder, which is 4. So now I have this keyword which is called as assert. So what is assert? Assert will just check. Okay, so this is just like test. Okay, it's just testing. Okay, so when I run this, assert does not if it is not equal, it will give a really blank output. If this is not correct, let's just say 4 is equal to 5, and when I run this, it will throw a big error. So that is about assert. So if it is not true, it will return a big error. It will just say assertion error. Okay, so now let's just talk about not equal. So not equal just means this exclamatory mark and equal sign. So that is not equal. So let's just do it with the example. Print, I'll just say 5 exclamatory mark equals to let's just say 6. Okay, so now if we just run this, it printed true. Of course 5 is not equal to 6. So now we are going to move on to the power notation. So you know power notation is just like if I say 3 to the power of 3, you have already seen it in the world's largest number video. So let's just say 3 to the power of 3 is just 3 into 3 into 3. This is 3 to the power of 3. Okay, so how to do that in Python? So you just have to say print, and then let's just say pow. Pow is just a short form for power. So in that you have let's just say 3 to the power of 3. Okay, so in that you have to pass the first and the second value. So 3 to the power of 3. Okay, so when I run this, it returns 27. So of course 3 into 3 is 9. 9 into 3 is 27. Okay, it's correct, right? Yes. So now let's talk about bitwise operators. Okay, so now let's look on some bitwise operators. So here are the bitwise operators you have. You have complement, bitwise AND, bitwise OR, XOR, and you have left shift and right shift. So now let's just start with let's just start with complement. So what is complement? So complement just means, let's just say to prove it to you more quickly, let me just do this. Let's just say print. So complement is just this tilde operator. So this tilde operator is just above your tab key. Okay, so now let's just say 12. Let's just say tilde, and then let's just say 12. Okay, so now we got tilde 12. So when I run this here, you get minus 30. Why minus 30? So here is how. Let's look at the complement operator. So the complement operator is just basically that tilde symbol over there. This is the tilde symbol, is just above the tab key. So now what this will do? To understand that, I'll just run this and show you. Print the complement of 12. It printed 13. minus 30. But why minus 30? You see, okay, so let's convert 12 into binary format, and if you convert it, you get this answer, which is 0001100. And when you just like so you see, in complement, everything is like that not a keyword I told you. So everything will just change. If it's 0, it will become 1, and if it's 1, it will become 0. And you can see we have this is actually the 12 in binary format, and this is the 12. This is the complement of 12, complemental binary. Okay, and then if we also convert 13's binary format and then into a complement, we actually get 1 1 1 3 4 1s 0 0 1 0, and then after that we add 1. Okay, so after that we get 4 1s 0 0 1 1, and if you see that this is similar to 12's binary format, so that's why. So 12's and 13's are same, so that's why it returned 13. Okay, so that's it for this complement operator. So now let's look at the bitwise OR. So what is bitwise OR? It's just on like normally like AND and OR, but like bits. Okay, so now if I just like say, now I'll also do this in a text format. So what this will do, we'll just say let's just say take two numbers, just 1 1 0 0 1 0 1 0 1. Now or let me just convert this as some number. Okay, so decimal to binary converter, because I'm just like tired of converting it, but if you want, you can just convert it if you want to. Okay, so I just convert this like 25, and then when I convert it, you get 1 1 0 0 1, and then let's just put this 25 is equal to 1 1 0 0 1, and now let's just add 20. Let's just add 27. Okay, so let's just convert this, and then you get. Oh, you're getting the same answer. Oh, you got a different answer. Sorry for that. So when I just copy paste this. I just say this is 27, and I'll just paste it over here. Okay, so you got it. Okay, so now let's just like so we've seen the AND and the OR table, right? So now what we'll do, we'll apply the same thing here. So as you can see, 1 1, so it's 1. Okay, so I'll just write it for you. So you have 1. Okay, just wait a second. 1 means true and 0 means false. Okay, yeah, 1. And then this will become so both of them are true, become 1. One of them is actually one of them is false and one of them is true, so it will return false, which is 0. And since both of them are 0, it will return 1. Sorry, 0 0. Sorry for that. 0. And then let's just both of them are same, so it's just the same 1 and 1. Okay, so now let's just put this back. So you can see that we have actually got the exact thing as we have here. We got the exact thing of 25. So and even if I try it here, over here, I just say print. Okay, so let's just say 25. But how do you put that OR symbol here? For OR, you for AND, you have to use the ampersand symbol, which is like that and thing. Okay, and then at the last let's just add 27, and now let's just run this here, and then you get 25. Of course you will get 25 because 1 1 0 0 1, because both of them matches, so you get 25. So same thing with almost the same thing with OR. Okay, I mean OR, yeah, OR. So now if I just okay, so this will be since both of them are 1, it will be 1. Okay, so this is one of them is true. It's okay, it's true. Both of them are false, so it's false. And then the rest of them are of course ones and ones and others. So as you can see, we got 27, both of them matches, and now I'll just run the OR one. So for AND we use ampersand, for OR we use that straight line thing, which is just like above the entry key. Okay, so now if I just run this, you get 27. So you got the answer. Of course it's 27 because both of them matches. So now let's talk about XOR. So what is XOR? So let's say that we have these 2 bits. Let's just remove this for now. Let's just say you have these 2 bits, which is both of them are 0. The output will be 1. It will be 0. So why 0? It is because, like, if both of the digits are equal, it is false. Okay, so if I say 1 0, it will be true because there are 2 different digits. Or you can say it like this. So 1 plus 0 is an odd number, 1. But if we do like 1 1, we get 0, because 1 plus 1 is equal to 2. So 2 is an even number, so you always get 0 for even numbers. So that's it for XOR. So now I'll just run this over in my IDLE, because Python is actually a little bit bad at calculating some stuff. So I know what Python calculates and which it does not calculate. So we got our Python IDLE here. Let's just open this. A shell here. So now here I'll just perform one operation. I'll just use our past answers, which are 0 0 0 0 1 1 0 1 0 1, and then 0 0 0 0 0 1 1 0 0. So this is actually 12 and this is actually 13. So what I expect to return is actually I don't know what I expect to return. So let's just say that let's go to a new line, and then here let's just specify some values. So let's just say now we are going to do the OR operation, but it's just something like that. So 1 and 0, they are both not equal, so it is true. And then second one is false, because and then this is false, and this is also false, and the rest of them are just false, because you see 1 actually has a lot. So this is the answer. This is 1, and then after that fully zeros. So when I do this operator in the IDLE, So for XOR you use cap. Okay, so cap is just a power notation like this. So this is okay. So I'll just say the cap of 25 and cap, I mean 12, and then cap, and then 13, and you get 1. So of course it's 1, because if even I'll just show you by converting this. Okay, so just wait a second. Yeah, I'll just control the copy, and I'll just go paste it over here, and I'll convert, and you get 1. Of course you'll get 1. So that's it for XOR. Now we are going to move on to left shift and right shift. So this concept is very interesting, you see. So what you people do in the left shift is that, so okay, so my cursor has to be here. Yeah. So now let's just remove these. Okay. Okay, so now let's just use left shift. So what is left shift? Left shift is like for any normal number. If you just do 24, of course it's 24, but if you express that number naturally, you have 0, 0, 0, 0, 0, and etc. So that's the same thing with binary. So let's just say the 12's binary. So it's of course 0, 0, 0, 0, 1, 1, 0, 0, and after that you get points. So I'll just say 1, 2, 3, and let's just say another number 0, 0, 0, 0, 1, 1, 0, 0. I mean this should be 1, and then points, and then 3 zeros again. So in left shift you shift 2 of the bits to the normal thing. So you just have to shift both of these bits where my cursor is to here. So what I mean is that I just remove this, and only this 0 will be here, and I'll just say 0. Okay, sorry. Okay, so I'll just do it by code. It's big because typing is actually hard here. So for left shift you actually use this thing. So I'll just say 12, left shift 13. You get some really big number, I don't know. But you get this really big number, and this really big number when converted to binary system gives us 98304. So that's the same thing with right shift, but in right shift you are losing digits. So I just says 12, left shift 13, and it just says 0 because we are losing bits. So now that's it for left shift, right shift, and all those operators. And that's it, everyone. Hope you liked the video. If you did, hit the like button, share with your friends, and never forget to subscribe and look for amazing videos. Bye.